Okay, we're going to look at our quadratic functions homework. We're only doing the front side, 1 and 2. Number 3 we'll look at later next week. All right, so we need to complete the square to write it in vertex form. So that's the form where you can see the transformations, like how it's moving up, down, left, and right. All right, so we're going to write g of x is equal to, the lead coefficient is 1, so that's actually really nice. So I'm just going to leave a little space after the 8x. And that's where I'm going to be able to add on the thing, the number, that makes this turn into a perfect trinomial square. So remember, we would say what plus what makes 8, or we can also say that as 8 divided by 2, which is 4. And then the number we add is 4 squared, or 4 times 4. So we're going to add a 16, and then minus a 16. And that's because that's adding really a 0. So we're making this look different, but it still has the same value. So the x squared plus 8x plus 16, that will factor to x plus 4. It's always the number that we got when we divided by 2. And then combining the two ending terms here, we're going to get a negative 9. And so based off of what we've learned with transformations, this plus 4 is actually moving us left 4. And that minus 9 is moving us down 9. So that puts us at negative 4, negative 9. And so as I'm kind of filling out the details here, I'm going to graph negative 4, negative 9 down below. So you can see I put a little dot there. And I know that my parabola is not being stretched or anything, and it's pointed upward. So I'm going to have these two other points on there where you go left, right, 1, up 1. Because again, our parent function is normally 0, 0, and then 1 gets you 1, negative 1 gets you 1. But we're transforming it. We're moving left 4, down 9. So that helps me out a little bit to identify my axis of symmetry. That's the line that will divide my parabola in half. So that's going to be x equals negative 4. Now to find the x-intercepts, remember that's where my y is equal to 0, because I'm not moving up or down, I'm on the x-axis. So I'm going to set my equation equal to 0. And you can solve this lots of different ways, like quadratic formula, complete the square. I like trying factoring, and it's a nice one to factor because I just have this nice x squared. So that's going to be x and x. And now I need numbers that will multiply to make 7 and add to make 8. If I'm thinking about the little x that we've done before, it's 7, 8. And so that's going to be a 7 and a 1. They multiply to make the 7, and then they add to make the 8. So plus 7 plus 1. Now you can check that that does make 8 by distributing it out, and I would check it if you're not confident in your factoring, but it will work. So now I'm going to use the zero product property that says that if those things multiplied equals 0, then each thing we set equal to 0, which gives us negative 7, and we'll have negative 1. So our x-intercepts, to answer the question here, are going to be negative 7, 0, and negative 1, 0. Those are my x-intercepts written as points. And so I'm going to zoom in a little bit so I can mark those on my graph. So I have negative 5 showing, so negative 6, negative 7 would be right here. Negative 1, 0 would be there. You can see my line of symmetry. I didn't draw it perfectly because it should really be dividing the parabola in half there. So if I had a straighter line, you can see that this is right in the middle. So 3 away that way, 3 away that way. So just showing that it is splitting the parabola in half because it didn't look like it. All right, one last thing to find, that's the y-intercept, and that we're going to let x equal 0. So really, if you evaluate that function, g of 0 is equal to 0 squared plus 8 times 0 plus 7. So we're going to get 7. So 0, 7 is the point. And again, all of this should make sense as you're putting it on the graph. So if you got like 0, negative 10, you know you did something wrong because there's no way that our graph would go through that point. So again, based off of symmetry, I can find the other point on the left side, and then I connect the dots, and I have this quadratic, which has domain negative infinity to infinity. There's no restrictions or anything. And the range, the lowest point, the minimum, is negative 9. And it's going to come up forever. All right, so then the next one, this one differs just a little bit because it has a lead coefficient that is not 1. So the first thing I want to do to complete the square is take that -3 out of those first two terms. That's going to leave me with x squared minus 4x. Again, I'm going to add something, minus something, and then the -7 is just kind of hanging out. So the thing that I'm going to add, again, we take -4, and you're like, what plus what makes 4? It would be 2. Or you could actually take -4, divide by 2. We know that's -2. But then the number that we actually write down here is -2 squared, which is 4. And then minus that same 4. So the whole point in doing that was because those first three terms will now factor to that nice quantity squared. It'll be x minus 2. So make sure that you're noticing that. Now, the -4 that I had in here, it's inside the parentheses. So in order to kind of kick it out of the parentheses, I'm going to multiply that, and it's going to be a positive 12. And then the -7 is still hanging out there. And -3 is still sitting in the front. So then I can combine the 12 and the -7 together, and it ends up I have -3 times x minus 2 squared plus 5. So again, based off my transformations, this is moving to the right 2 spaces. This guy's going to move up 5, which is going to put me at 2, 5 for my vertex. My axis symmetry, it'll go right through the vertex vertically, so we'll have x equals 2. Now to find my x-intercepts, again, I'm going to let y equal 0. And so I'm going to get 0 is equal to -3x squared plus 12x minus 7. Now, you can try and factor that, but it's actually not going to work. If we would factor that, we're trying to complete that little x. If you remember, AC goes on top, so it would be 21 on top, 12 on the bottom. There's no numbers that will multiply to 21 and add to 12, so it doesn't factor. So we have to use the quadratic formula here. And the quadratic formula says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And the a, b, and c, the a is the -3, b is 12, and c is that -7. So I'm going to sub in there. Let's kind of leave the sign so we don't get confused with that stuff. And so I'm going to plug in. So -b would be -12 plus or minus the square root of 12 squared minus 4 times -3 times -7. And so we're going to get x equals -12 plus or minus the square root. We'll have 144 there. And then the 4 times -3 times 7 will be 12 times 7 will be 84, and that will end up being -84 over 2. And I just looked back, I realized I didn't divide by 2a, right? It's 2a, so that means 2 times -3, 2 times -3 right there, which would be actually -6. So then we have -12 plus or minus the square root of, that would be 60 over -6. Now that's pretty good. We can work on simplifying that if we want to simplify our radical, but if you punch that into your calculator, there's really two things here, both -12 plus the square root of 60 over -6, and then we have the minus, which should get you about 3.3 and 0.71. Again, we could have simplified before doing that. It's kind of fine though, but to see the simplifying, 60 is really like 6 and 10, and 6 is 3 and 2, and 10 is 5 and 2. So because I have a pair here of 2's, it gets to come out of the square root. So I'll have -12 plus or minus 2, and then 15 would be what was left over out of all those factors. And then this is all over -6. Then we can simplify by dividing all three of these by 2. Call it sometimes like a Mickey Mouse. So that will be x equals -6 plus or minus the square root of 15 over -3. Okay, so we could have it like that. And then if you punch it in your calculator, you get those two. So just putting those zeros in, about 3.3, it's just a little sketch, it's not perfect. And then 0.71, a little less than 1. So it looks like those are going to be where our x-intercepts are. Going back, our vertex was 2,5. So just making sure we got that. And remember, if we think about our transformations, that -3, it's a reflection, so we know that part. And it's also a vertical stretch by 3. So if I go back down and use that to kind of get some more points on my graph, that would mean I would go left 1, not down 1, because that would be the normal structure. Because we're multiplying by 3, it's 3 times as big. So we're here, and symmetric, it would be here also. All right, one more thing to find, and that's the Y-intercept. That's plugging in a 0 to our function, which is function h up there, h of 0. Everything will become 0, except we'll get a -7. So 0, -7. And for my x-intercepts for this part, I forgot to list them. I would have -6 plus the square root of 15 over -3, 0, and -6 minus the square root of 15 over -3, 0. Those would be my x-intercepts. So just going back over to there. All right, so to get 0, -7 on my graph, that would put me down here. And so playing connect the dots, we would have that guy and that guy looking beautiful. So my domain, -infinity to infinity, no restrictions on that. My range, this time because it's going downward, it's going to come from -infinity and then be all the way up at that y-coordinate of our vertex, which is 5. And so there you go. There's our two quadratics. Again, we're going to skip that for now. We'll come back later.